Okay, another video. This time I want to talk about two different geometries and how it affect the residual time distributions. Why? Because I like to compare everything I learned in my advanced reactor design with CFD here. So in this little video here, I'm going to show how this geometry here is related to this RTD there. So these are the two geometries I'm trying to replicate a continuously stirred tank reactor. This one is short, so I'll call it the short one, and this is tall, so I'll call it the tall one. So now I'll talk about what I did for the simulation parameters. I used openFOAM. I kept the simulation parameters equal because I just wanted to see how the flow changes with the different geometries. I assumed a steady state. I used simple foam. I used laminar as the turbulence. Everything else is similar to what I did to the previous videos on my RTDs here. So if you want to see any details, you can look at my previous videos. And now we're going to talk the short cylinder. As you can see, we have a bypass. So as you can see, the time from my concentration curves from the openFOAM is 116 seconds, where the resonance time from the geometry is 48 seconds. That makes sense because when you have a bypass, if you're not inside the bypass, you stay a little longer in the tank. And the bypass is right up here. We're going to flow in here. And this gray area means it's a little faster than this blue area, which no movement. And then it just comes down and goes up. All right, so then here's my normalized geometry here. You can see that the geometry residence time, this curve drops steeply, which is a little not what I expected, or not what you would expect, I guess. Instead, we had a much more shallower decrease here, which is a little counterintuitive because you think since there's a bypass, the concentration will go down real quick, but it doesn't, and I'll show you why. It has to do with the exponential terms here. When you have the residence time from the geometry, 1 over it is larger than the 1 over the residence time from concentration data. So the calculated from the residence time distribution has a much shallower decay as compared to the one from the geometry. So that's why you see that. And the next one. All right, the tall cylinder, we have the Z zone behavior, where again we have the gas flowing through here at high speed, and it sort of hits the wall, and then we sort of have this gray area here going down, and then kind of diffuses out, and then we got fast velocity coming out, and possibly some dead zones up in here and here, and which shows out in our curves here. And yeah, our time based on the geometry is 145 seconds, where the time, residence time from the concentration data from the simulation is 76 seconds. This tells us there's a dead zone and the gas is moving a little faster, but we're not going to get anything that's stuck in there too long like the bypass. And here are the curves. The blue one is what I call the real, or what was calculated from the openFOAM, and the green here is what was calculated from the geometry alone. which is for a dead zone behavior is what you expect. And all right, and that's now when you can compare the two because I use the normalized RTD here. You can sort of see that the short one has this real slow decay, and as the tall one has this faster decay. So again, maybe you can sort of say that the longer the the tube has a difference than the shorter tube, where the shorter one will actually show the bypass, and the longer will show a dead zone behavior. That's all I wanted to do for this video, because I think it shows that different geometries can affect the residual time distributions, and from the geometries also. And that's it. And maybe I'll do some more later if you like this one.